We are going to start with a quick review of graphing and what it means for a coordinate to be a solution. So the equation y equals negative 2x plus 3. The plus 3 is called the y-intercept. That's where I'm going to start on the graph, at positive 3 on my y-intercept. The negative 2 is called the slope. That means that from that starting dot, we are going to continue the pattern by going down 2 and over 1. We're going down because the slope is a negative number. Down 2 over 1. Down 2 over 1. Continue the pattern and draw the line all the way across the page as best we can. Is the point negative 1, 5 a solution? I can check that in two ways. I can look on the graph. If I go to the coordinate, negative 1, there's negative 1, and up to 5, 1, 2, 3, 4, 5, I can see that the coordinate negative 1, 5 is on the line. So I would say yes, it is a solution. I could also check it by plugging in negative 1 as the x and 5 as the y into the equation. So instead of y equals, it would be 5 equals negative 2. Replace the x with the coordinate negative 1 plus 3. And then we can calculate. Negative 2 times negative 1 is 2 plus 3, and that does equal 5, so that's why this coordinate was a true solution. We can check the point 2 comma negative 1 by going over to 2 and down to negative 1, and yes, 2, negative 1 is also a coordinate on the graph, so we would say yes, it's a solution, and we could check it by plugging in the x and the y coordinate into the starting equation. So instead of y equals, negative 1 equals negative 2 times the x2 coordinate plus 3. So if we multiply the negative 2 and 2, we'd get negative 4 plus 3, which is negative 1, so it works. The last example, 0, 0, if we look at the graph, the line is not crossing through 0, 0, so that would be not a solution. And if we tested it into the equation, 0 does not equal negative 2 times 0 plus 3. That would say 0 equals 3, which it does not. Cross it out. Now that we've had a review of graphing, let's look at what would happen if this was instead what's called an inequality. So you'll see that instead of the equal sign, we have this inequality symbol. The equation has not changed. It still has the y-intercept at 3 and the slope of 2. So I'll get that graphed on quickly. Because the inequality has the equal to line here under it, equal to means the answers can be exactly on the line. So when we mark the line on our graph, we're going to make it a solid line saying, yes, these answers on this exact line will work. Then what we need to do is, because it's an inequality, we're going to have a situation where all of the points either above the line or all the points below the line are also going to be examples that work. So what we do is we can pick any coordinate position on the graph that's not already plotted on our line. So I like to pick the coordinate at the origin, which is 0, 0. I'm going to use 0, 0 and test if it's true. If 0, 0 is true, then that means this bottom side of the line can get shaded. If it's false, we know that those are wrong and it's not the right spot to pick. So here we go. If we plug in 0, 0, replace the y with 0, replace the x with 0, and then we check, is 0 smaller than or equal to? Negative 2 times 0 is 0, and plus 3 would be 3. Is 0 less than or equal to 3? Is 0 smaller than 3? Yes. So that coordinate worked. So when I go over here, 0, 0 is a true point. It works. So any other spots that are also on that same side of the line will all get shaded. This is all what's called a true solution region. Any of the solutions, any of the coordinates that are colored there in red would all work in this inequality. If we picked one on the top side of the graph, up here, when we plug in this coordinate into the inequality, it's going to be wrong. And we can look at an example of those next. Here's one more that we're going to graph. This time the numbers are different. We're going to start at a y-intercept of -4, and we're going to follow the pattern of a slope of 3. So we're going to go up 3 over 1, up 3 over 1. This time our inequality symbol does not have the equal to line under it. That means that the points on the line are not equal. They don't work in the inequality. So we're going to make what's called a dotted line. We're going to dash connect these, but not solid line connect them. And this dash just reminds us that this line is a boundary, but not a solution. So I wrote us a little note at the top that if it's a greater than or equal to, we connect them with a solid line. If it's a less than or greater than, but does not have the equal to, then it's going to be a dashed line across the page. Once we've graphed the slope and y-intercept and we have the line, we pick any coordinate on the graph paper to test to see if it's a solution. So I'm purposely going to pick one that I know as the teacher doesn't work. Say we pick the coordinate that is over here. This coordinate is over at 3 and down at -2, 3 comma -2. So if I go to my equation and I plug in 3 as the x and -2 as the y, -2 is greater than 3 times 3 minus 4. 3 times 3 is 9, minus 4 would be 5. Is -2 greater than 5? No. So this coordinate that we picked does not work. This is not the side of the graph that we would shade in. Instead, we should pick a coordinate on the other side. It's not true that always 0, 0 works, but it's the easiest numbers to plug in. So if I plug in 0 and 0, 0 for y, 3, 0 for x, minus 4. 3 times 0 is 0, minus 4 is -4. Is 0 greater than -4? Yes. So that means the proper side of the line, that all the solutions that are on this upper part of the line are possible, or the left-hand side of the line. Anything along next to 0, 0 would be a possible solution. So overall, you're going to graph the line with the slope and y-intercept, decide if it should be a solid line or a dotted line, and then test a coordinate to see if it works in the inequality. If the inequality is true, then you shade that side of the graph where the coordinate was. If it was false, you know it's wrong, and you would have to shade the opposite side.